Hello all, in this video we will see how to interface a light sensor to a Raspberry Pi board. So basically light sensor is a photoresistive device kind of sensor where based on the light intensity the resistance of this particular sensor that you see here is going to vary. So as the light increases the resistance reduces. That's how the property of this sensor is. Now if you see here, this is a small circuit which is already built actually. Okay, so you have this on a PCB where you can see here there are 3 pins, and as we get closer here, okay, so you see there is a plus sign, there is a minus sign, and then there is yes sign, which means signal. So this will provide analog output out of this pin, and to the plus sign we have to give the voltage, and this voltage specifically will be based on the voltage that is compatible to your particular board. For Raspberry Pi the pins are 3.3 volt compatible, right? So we give 3.3 volts, and this particular circuit, even though this PCB looks too complex, it's just a resistive divider, and you have photo sensor and a resistor in series, and with one end connected to 3.3 and the other end in that series is connected to ground and the middle point connection of this particular combination is provided to the Raspberry Pi connector. Okay, now the biggest challenge with the Raspberry Pi board is we don't have analog input on Raspberry Pi. That's one of the biggest challenge that you see here. So as the Raspberry Pi doesn't have an analog input, right? We need to use analog to digital converter such that the analog output of this particular sensor will be connected to this particular ADC, and then the ADC output, which is a I2C, will be connected to the Raspberry Pi. So that's how this entire connection will be made. So if you are a beginner and you are not sure what this photoresistor meant, okay, we can see here. So this is a simple circuit. You can search photoresistor circuit or light sensor circuit in Google, and you can see there will be number of circuits popping up. So this is a simple circuit, and you can see here there is a photo resistor which is placed, and then there is a resistor here, and to this there is a 5 volts connected. As we mentioned, we will be connecting 3.3, and then the center tap of this particular resistor and photoresistor will be the Vout, which is the analog input, which we will be connecting to the ADC. Remember that photoresistor is not a polarized one. Polarized in the sense it doesn't have any asymmetricity with respect to its connectivity. You can connect in any way. The pins of that particular photoresistor can be used interchangeably. That's what we mean. Okay, so that's how you use the resistive divider combination. Now this particular output, as we mentioned, will be connecting to ADS1115 analog circuit. Now coming to ADS1115. So basically ADS1115 is a simple 4-bit 4 input 16-bit ADC, and this has a I2C interface to as a digital output from the sensor. And as we see, this is the block diagram of ADS1113, 4 and 5. So there are 3 different models in ADS1111. Generally we call it ADS1111X. X changes by the last digit. Okay, and then now if you see here for ADS1113, there particularly is two analog inputs, and then there is no alert or ready. Whereas ADS1114 has alert or ready and two analog inputs. ADS1115 is little more extended version of this particular ADC, where you have four analog inputs. Okay. Along with these analog inputs, you have a VDD. Definitely, you need power, right? And then there is a address bit, which is input to this particular ADC, and you also have alert and ready with SDA CL, which is I2C interface. Now, as you scroll down the data sheet, okay, what should we do? Okay. So basically what happens is you can connect it to any of the analog input. We'll try to connect it to A and 0. Okay, and then we will for now ignore this particular pin. We might not use alert already. Okay, and we will use SCL SDA to connect it to the Raspberry Pi, and then the VDD. So if you little scroll down, you can see here this particular sensor recommended operating conditions is like 2 to 5.5 volts. So you can have 3.3 volt connected to this particular sensor. You can give 3.3 volts because 3.3 volts is what levels we expect on Raspberry Pi, right? So that is how we connect connect the power supply. So we are clear about I2C interface. We are clear about the voltage that is to be provided to this ADS1115. And remember that pull-ups are required for I2C interface, and that is already present on the ADS1115 board that we have shown. Okay, and if you scroll down a bit, okay, you can also see application circuits, which you can, so any data sheet will provide application circuit, okay, and you can use that particular application circuit to connect your sensor. Okay, so you can see here, this is one simple basic hardware configuration which is provided, and you can see VDD 3.3 volts, and there is a decap, and ground address is also grounded. Okay, SCL SDA, and they haven't used alert, which we will also be doing the same. Okay, and one very important point for any I2C based device is its address. So now finding the address of ADS1115 is what we have to do. So as we have seen in this particular chip, the ADS1115 chip, there is a ADDR pin. So ADDR pin connection can be connected to ground, can be connected to VDD, can be connected to STA or SCL. Based on any of these combinations, this will be the target address. So if we will be connecting it to ground in this particular scenario, so that means the I2C address will be 1001000B. That means this actually becomes 8 and so to 48 will be the address of this particular sensor. Okay, so now let us try to see the connections on the board before going to the code. So here the ADS1115 is used as an interface between the light sensor analog output and then the Raspberry Pi 4. Okay, so now if you see here in this light sensor, the 3 pins are connected, and if we turn back, you can see the S signal, which is the analog output, which we connected the green color. The green color is actually connected to the A0 pin, the analog input pin of ADS1115, and then the power supply is actually connected in node fashion here, where this particular connections are first routed to ADS1115, and then from the Raspberry Pi it is distributed. So basically kind of a star routing here. Okay, and then here if you see the third pin is ground here on the Raspberry Pi 4, which is connected to the ground of ADS1115, and then the first pin is 3v3, which is connected to the 3v3 of ADS1115, and SCL SDA, which are I2C pins, are GPIO 3 and 2 respectively, and they are connected. Okay, so now let us try to code and see how this particular board works. So we have Virtual Studio Code open, and in this we are trying to connect it to our system. Okay, so let us enter and first go to Remote Explorer. Okay, and let us try to enter our password. Okay, and you can see the board got connected. Okay, Raspberry Pi local got connected, and we already have the sensors connected to our Raspberry Pi, right? So let us go to now in this particular Virtual Studio Code. What you can do is you can go to View and go to Terminal. Enable the terminal here. It enables the prompt. In this, first install the Adafruit packages. Okay, so this is the command to install the package. The ADS1115, we are using the JIT code that is available from Adafruit, and click enter. Okay, so it will install the required code, and now we already have a particular code available. Open folder. What you can do is in this folder, okay, you can see all our once it is connected to remote, you can see everything that is present on the SD of Raspberry Pi. And here as we go, okay, right now we don't have anything. Okay, and as we show here, so basically we have to have some code, right? So let us try to open a new new file. Okay, and it asks whether it's a text file or Jupyter notebook or Python file. We are going to have a Python file here. Okay, and it opens up a Python file, and we are going to just copy the code that we got from Adafruit base, and let us try to save this. If you do Control S, it does ADS1115 Pi. Okay, it saves as ADS1115. It is saved. Okay, now even if you open the folder, okay, you must be able to see ADS1115. Okay, and then once the code is done, okay, now we can run Python 3. Sorry, not here. In the command prompt, Python 3 ADS1115. We are running the code that we have seen there, and you can see it reads the analog values. Now we are actually going near the sensor, and we are actually blocking. You can see here the value changes. We are moving away from the sensor, and you can see that the value has changed. So this is how we can use Raspberry Pi to code the light sensor.